I've got another quadratic equation here. Can you please sketch the parabola related to this quadratic equation? In doing that, show the axis-intercept, show the turning point. Can you also please state the domain and range and axis of symmetry? Have a go at that, and I'll come back in a few seconds. Now, this doesn't look like it's going to turn into nice factors. So what I'm going to do is I'm going to jump straight into the quadratic equation for this one. X is equal to negative b plus minus the square root b squared minus 4ac all over 2a. Now, as far as I'm aware, this formula isn't included in the formula sheets for your external exams, so you want to actually remember this formula. X is equal to, okay, what are our a, b, and c coefficients? So a is equal to 5, b is equal to 5, and c is equal to 3 on 2. Plugging these into the equation, we have negative 5 plus minus square root of 25 minus 4 by 5 by 1 all over 2 by 5. X is equal to negative 5 plus minus square root. Sorry, C wasn't 1. C was 3 on 2. So negative 5 plus minus 25 minus 20, 60 on 2 all over 10. X is equal to negative 5 plus minus. Scaling this up to have the same denominator as 2, we have 50 minus 60 all over 2 over 10. Okay, what I'm seeing here is this looks like square root is going to end up being negative because you got 50 minus 60 on that numerator there. A negative discriminant means that your graph, if you're remembering this from the last lesson, is either going to look like this or like this, where there aren't actually any x-intercepts for your parabola. Seeing as that's the case, we don't need to finish solving this in terms of that square root, seeing as we're just after plotting it. Now, we know that that negative b on 2a value is the axis of symmetry. So, axis of symmetry, x is equal to negative 5 on 10, which is equal to negative a half. Seeing as our a value is positive, we're going to have a graph that looks like this. So it's not going to be the one that's on the bottom there. Taking what we know and putting it onto the next page. So redrawn on the next page, rewritten out the equation, the axis of symmetry. The graph is going to look like this, remember? So if we put in the axis of symmetry as this dotted line, for the graph to look like this, that means that we're expecting the turning point in the y side of things to be positive. So let's have a look at this. The process that we apply for this one is we sub in that known x value within this quadratic equation to see what that y value would be. So y of negative a half is equal to 5 times by a half squared plus 5 on 2 being negative plus 3 on 2. So y of negative a half equal to, so that's going to be positive, that's going to be on 4, so 5 on 4 minus 5 on 2 plus 3 on 2. Okay, so let's simplify as we go. So we have this one on the 2 as the denominator, this one on 2 as the denominator. That's equal to 5 on 4. So 3 minus 5 is minus 2 on 2. Let's scale this up to denominator of 4. So 5 minus 4 is 1, 1, 4. So y, negative a half, is equal to a quarter. Now, bad practice to leave floating equal signs, so let's just fill this in as well. Okay, so our y value is negative a quarter. Sorry, positive a quarter. Let's say it's about there. Next, we want to look at where the y-intercept is going to be. Now, remember, with this one, we're just plugging in x equal to 0. Just plugging in x equal to 0 to find out where that value is. So x equal to 0, we'll be left with positive 3 on 2. And that would be our quadratic equation now plotted. Next, we wanted to also state the domain and range. So the domain, we can see that the x values are going to keep going to the left and to the right as we are able to plot this. So the domain is going to go from negative infinity to positive infinity, which we're summarizing as all real values. The range, again, it's going to go down. Sorry, again, it's going to go down to the turning point. So it's going to be negative a quarter. It's actually going to hit that value. Sorry, positive a quarter. And it's actually going to hit that value. And then it's going to go up to positive infinity. That would be the domain and range for that question. Now that you'll also hopefully have noticed that when you go through the process of trying to find the x-intercepts using this quadratic formula, what you're actually doing is solving the quadratic. So when this is equal to 0, you're solving for x. So you're solving the quadratic. So you might have a worded question, for example, that after you figure out what the numbers and letters all piece together in terms of an equation, come out like this. And you may be asked to solve for x. So again, you can apply that quadratic formula to solve the quadratic equation. Now, when you have a question like that, you again want to get it into the form of ax squared plus bx plus c, and you want that to equal to 0, because remember that quadratic equation is derived for y equal to 0. So your first step in a question like that would be to arrange it into that form. Now, in this particular case, you'll just be moving the 5 over to the other side, or in other words, adding 5 to both sides of the equation. And then you've got your A value, B value, and C value. Plugging these in. Now, noticed in the last question, I made a mistake with that C value. So if that's a common, for me at least, if that's a common source of error in my calculations, I make the conscious decision to add in the extra step to mitigate those silly mistakes. And you can do that with any aspect of the math that you're doing. So for me, I wrote in every term prior to doing the simplification. Now, if a question like this pops up and it doesn't say to do it tech-free, you could also put this into your graphics calculator at this point to solve that function. The minus minus being positive, so plus 20. So this looks like it's going to be positive this time. So remember, if you have a positive value within the discriminant, you have two solutions. Now, when you have two solutions, it could be the case that one could be a valid solution and one could not be a valid solution. And that comes into account when you're applying your context to the situation initially. So if you were creating this formula from some worded question and it turns out that x has to be positive, Well, once you have your solutions, you can go back and apply that context and say whether or not they're both valid or just one of them is valid. Now, I don't think square root 69 is a complete square. So what we're going to do is we're just going to plug this into our calculator at this point, if we weren't solving it via a graphics calculator, and then we're going to combine it with the other stuff. So we go 6 over -2. So plugging this into the calculator, we get one of our solutions to be negative 0.6533. And the other solution we get as x is equal to positive 7.6533. Now, again, that could have also have been the first step in plotting the equation. So if you were given a question where it was already in this structure and it says to plot, you can apply this method and that'll give you your two x-intercepts. Alternatively, you could have been given a question that it was worded, it started out like this, and it was just saying solve for x, at which point you don't need a plot, but you can still use the same steps to find what those x values are. Okay, next question. Let's say again we got a worded question and it simplifies to this, where we're asked to solve for t, where t is time, and it must be positive. So have a go at solving this quadratic equation, and I'll come back in a few seconds to go over it with you. So the first thing we want to do for this question is to rearrange it into the form ax squared plus bx plus c. So we have 0 is equal to 0.1 t squared plus t minus 9.3. Again, we're using the quadratic formula for this one, but we're making sure we're noting it as t is equal to, not x is equal to, because there is no x in this question. And we want to be consistent. If we start putting in x is equal to or y is equal to for a question that doesn't contain those variables, you're not going to get marks because those variables aren't in the question. But t is equal to negative b, so -1 plus minus square root of b squared minus 4ac all over 2a. Again, you can just plug this into your graphics calculator to solve it, or we can do the few extra lines in a scientific calculator. 0.72 all over 0.2 minus 1 plus minus 2.172. And simplifying this, we get two solutions. T is equal to 5.863 and t is equal to minus 15.863. Okay, we've got our two solutions now. And for this particular question, there was an extra line where t must be positive. So we're applying this context to our two solutions, and we see that only one of these is valid. So our t value is 5.863. Okay, I've got another equation here. Can you please solve for x? We'll come back in a few seconds and we'll go over this together. Okay, this one was a little bit tricky to start out with. What you're wanting to do is get rid of these denominators. So what we're going to do is multiply every single term by x squared. So this becomes 1x squared is equal to negative 6x squared on x squared plus 5x squared on x. You can see these ones divide out. This divides out with that. And we're left with x squared is equal to negative 6 plus 5x. We then want to rearrange this into our ax squared plus bx plus c formula. So we have x squared minus 5x plus 6 is equal to 0. And we can then, this looks like something we could decompose. So we could go 1 times by 6. 6, what are the factors of 6 that add to 5? Well, you could have negative 2 and negative 3 that add to 5. So we have x squared minus 2x minus 3x plus 6 is equal to 0. So we're factorizing out x from these first two terms, leaving behind x minus 2. And then what do we need to factorize out from these second two terms to leave behind x minus 2? Well, it's a minus 3, leaving behind x minus 2. So you're factorizing out the negative as well. So leaving behind the negative 2 is equal to 0. Now we can factorize out x minus 2 from both terms, leaving behind an x minus 3 is equal to 0. And so our two solutions for this using the null factor law is when this set of brackets is equal to 0, or when this set of brackets is equal to 0. So we have x minus 2 equal to 0, which gives us x equal to 2. And we have x minus 3 is equal to 0, which gives us x is equal to 3. And so those are our two valid sets of answers for this initial question.